Hi, everyone. Welcome to Warwick and welcome to the economics department. My name is Lory Barile and I'm an associate professor in the economics department. Just to give you, sorry, before we go to this one, just to give you a little bit of background about myself. I'm a behavioral environmental economist. And what I'm going to do today, during this time, is to give you an idea of how a lecture with me could look like. Okay, so I'm going to talk about something that links to behavioral economics and also to environmental economics. So now, you have already seen this slide. You might now wonder, what has this to do with economics? So what we have in the slide, I'm sure if you are a television fan, you should be familiar with these characters. So we have Homer Simpson and Spock from Star Trek. You might know, maybe not, that this is all linked to nudge and nudge theory. So for those who are familiar with nudging individuals, you probably know that a nudge is any feature in the environment or in our choice architecture that attracts our attention and influences our behavior. You may not be familiar to this, but I think that probably there are lots of people in this room that have been exposed in a way or another to a nudge, okay? One of the most familiar nudge that I think we can all remember from the COVID pandemic is the stay safe, keep your distance nudge, okay? Just to give you an example. But the idea of nudging people is based on a theoretical framework which is called libertarian paternalism, which basically is based on the idea that we try to influence people in a way that keeps their freedom to choose. So we are exposed to these nudges, but nudges are not mandates, okay? And they shouldn't change our incentives to behave. So we can actually decide whether or not we want to engage with the nudge. That's the idea of libertarian paternalism. And now, going back to the previous slide, how is this all linked to Homer Simpson and Spock from Star Trek? Well, the idea is that nudging individuals or nudges have been designed to correct some of the mistakes that we make as individuals, not because we are unable to make decisions that are in our own interest. Most of the time we are able to do that, but sometimes we all have a busy life, do we? We have children, you are here with your children, and most of the time we do things in a very automatic way without reflecting too much on what we are doing, okay? When you brush your teeth in the morning, you're not really thinking about the amount of water you are using and how much CO2 emissions or you are producing, or water scarcity, or all of these problems in the morning, right? All you want to do is just get ready, go drop your children to the school, and then go to work, okay? So basically, this is just to say that most of the time we do actions, we act in an automatic way without thinking too much about the consequences of our actions, because we have limited attention, we have limited information, we have cognitive limitations, or abilities, and self-control, okay? So how many times you go to the restaurant and you feel like, I shouldn't get the cake, okay? It's not good for my diet. But then at the end of the dinner, you feel like, okay, let's get the cake, okay? So that's what we mean with lack of self-control, okay? Temptation. We are all subject to this in our daily life, right? So that's why, scholars have started to think about possible ways to help us to make decisions in our own interest to stop us to, do the wrong thing in a way. And that's how Homer Simpson comes into the discussion, okay? So in the book, I don't know if you've read these two books written by Richard Thaler and Cass Sustein on nudges. There are two different editions of this book. First one published in 2008. Second one, the final edition, published in 2021. The final edition is actually a nudge itself. So the authors have used basically a nudge to stop themselves to think about a third edition of the book. And in the book, the authors talk about humans as people that act like Homer Simpson. You know that Homer is really, really attracted by donuts. And so he's system one, so the automatic system, when he sees the donuts, cannot be controlled, right? And so in the book, they talk about humans that act according to the automatic system and econs that are more reflective persons, and they can use their mind and their reflective system to stop making, or let's put it this way, to make decisions that maximize their own interests. So they are basically in line with what we call in economics rational behavior, where with rational behavior we don't necessarily mean emotions against the use of our reason, but we mean basically decisions that are based on the idea that we try to maximize our payoffs, we try to maximize our own interests and outcomes, okay? So that's how Homer Simpson and Spock relate to nudges. Homer is acting according to an automatic cognitive system, and Spock is acting according to a more reflective system. And if you are interested in reading more about this, you might want to look at another interesting book, which is Thinking Fast and Slow, written by Daniel Kahneman, another Nobel Prize psychologist that received the Nobel Prize for his contribution to economics and behavioral economics, okay? So it should be now clear how these sort of concepts link to something I'm really passionate about, which is behavioral economics, and I will present a paper that is not just linked to behavioral economics, but also to neuroeconomics. So behavioral economics is basically the discipline that is using some psychology in the field to understand how people make decisions, so human decision-making processes, whereas neuroeconomics is an interdisciplinary field that is not just looking at how people make decisions, but it's looking at how our brain works when we make decisions, right? So this should also highlight how economics is an interdisciplinary subject. Okay, so the paper I'm going to present, which links to my area of research, is a paper that is joint work with Lorenzo Lotti and Giovanni Manfredi from UCL, and it's looking at improving recycling sorting behavior with humanized nudges. Now, the reason why we started to work on this project, very simple motivation. You might know that recycling is actually, fixed or stable at a certain rate in the country. So we've reached the point where, let's say, 45% on average of our waste is recycled, but there's been no improvement over the last few years. And higher education has actually seen a decrease over the last few years. This might be due to many different reasons. Even in the UK, there's not a harmonized, policy of regulation on recycling. So people are coming, I would say higher education campuses are international environment, multicultural environment. So this obviously doesn't help because we come from different places with different regulations and people might be confused about what they need to do. So what we wanted to see is whether, using a simple nudge, we could improve the recycling rates in a UK campus. So we did this experiment at UCL. And what we wanted to test is whether a simple visual nudge, so basically the idea of having somebody that is watching you can help increase in recycling behavior. The idea behind this experiment was linked to the fact that sub-tools of observability have been effective in other contexts, in the littering literature, and in the bicycle theft, so at reducing littering and basically bicycle theft. So we wanted to see whether it was also effective in this particular context, especially to help people to internalize the injunctive norm. So basically to internalize the fact that the right thing to do is to recycle what we use, our waste, okay? And I said it links to neuroeconomics because according to neuroeconomics, when we are in proximity of the eyes, there is something that basically impacts our neuronal system and makes, and activates our neuronal system and help us to make pro-social decisions. This, as I said, was proven in other contexts, and we wanted to see if recycling is also a context where this could help. So what we did in the paper, or our objectives, were to test whether human eyes are able to activate the motivation to comply with the norms, when these eyes are combined with instructions. So the benchmark situation at UCL was that they already had bins with some instructions on top of the bins describing what people had to put into the receptacles. And so we thought maybe if we couple this nudge, which is an informational nudge, with human eyes, we might be able to attract their attention more and increase recycling rates. The alternative explanation that we had in mind why people could increase their recycling rates is because they internalize the injunctive norms simply because they are worried about somebody watching them, okay? So we designed the experiment to test these two different hypotheses. And then the other thing we wanted to see, because there's a lot of literature about nudging people and what works, what doesn't work. And one of the limitations of these nudges is that when you remove them, sometimes people stop doing, the desired behavior. So we wanted to look at the long-term effect of this nudge. So this is, in terms of the methodology, as I said, the benchmark situation was a receptacle. You see the receptacle there with a non-recycling, mixed recycling, and food recycling bin. So the black one is the non-recycling, the green one is the mixed recycling, and the orange bin is the food waste bin. And so what we did, we designed an experiment with a control group where basically we didn't change anything in the benchmark situation. And then we had a treatment with what we coupled the human eyes with the instructions, which is treatment 1, and then we had another treatment where we removed everything, so both the nudges, if you want, the information nudge plus the humanized nudge. And people had to put that waste in the receptacle. As I said, they were used to the colors because this was the benchmark situation. And here you can see the experimental setting, so what we've changed in order to to have these different treatments. So this is basically the benchmark situation. These are the kind of instructions. It's all about explaining people what was meant to go into the different bins. And here you have first panel in the picture. Panel A is a benchmark situation. Treatment 1 is the one that couples the humanized nudges and the instructions. And treatment 2 is the one with only the humanized without the instructions. So what we did, essentially, going back to the introductory part of this lecture, is basically we tweaked something in the choice architecture, so in the environment where we make decisions, in order to exploit the system 1, so the automatic system, to increase recycling rates. Okay? Now, this might sound a bit more complicated than it is, so stay with me and I will explain you what the diagram is telling you. So we looked at, what we did is we looked at the sorting errors, so we calculated and monitored for 9 weeks the different receptacles that we decided to look at for the experimental period of time. And we calculated the sorting errors as basically the number of times people were misplacing items in the bins by the weight, the average weight of these items, okay? And we divided this by the total weight of the bin in every single day for a period of 9 weeks. In the diagram, in the top panel, what you see is the number of errors on the vertical line plotted over the period of time we did the experiment. There are 2 different lines. One is the control group, and one is the treatment. In the top panel, you have treatment 1, the results for treatment 1. In the bottom panel, you have the results for treatment 2. And you have this information for all the bins that were included in the receptacle. So the non-recycling, mixed recycling, which is the one in the center, and then the food waste bin. Now, if you look at the diagram, the vertical lines, the red vertical lines is actually related to the time where we introduced the intervention. So basically, we decided to put the humanized on top of the bins. And then the blue line is the time where we stopped the intervention, and we kept monitoring the errors to test the long-term effect of the nudge intervention. So I hope now it's clear what is included in the diagram. I'm just going to discuss now the results very briefly. So what happened, and I think the best way to look at this is to focus on this diagram here, because I think it's the clear sort of example of the bins and the effect of the humanized nudges. So you see that you have the 2 lines go together, okay, until we introduce the humanized. And then you see that in the treatment group, when we couple the humanized with the instructions, the error rates, the percentage of errors in the bins start to decrease compared to the control group. So this is basically the bins that didn't receive any sort of intervention, okay? And then after we remove the intervention here in the blue line, so after we remove the humanized from these bins, you see that people start to make the same mistakes. So the error basically go back to the original rate. So we controlled this for all the bins, and basically, and then we did some econometrics, to test whether the intervention was statistically significant. And what we find as a result of this experiment is that when we couple the humanized nudge with the information, so in treatment 1, the percentage of errors is decreasing by 64%, 95%, and 58%, respectively, in the non-recycling, mixed recycling, and food waste bins. Although for food waste, we didn't find any significant results. For treatment 2, which is the bottom panel of this figure here, we actually find that when we have only the humanized in all bins, the mistakes tend to increase. So when we remove the information, all the errors, the percentage of errors started to increase compared to the benchmark situation, okay? So what did we conclude from this experiment? We concluded that, so the nudge, the watching eyes effect is actually working when we couple this nudge with the information. At least this is what we can see from the non-recycling and mixed recycling bin. This seems to point to the direction. I mean, if we think at the drivers of this kind of behavior, because of the hypothesis that I mentioned before, it seems to be due to the fact that the eyes are keeping the attention of people to the information that was provided. Because when we remove the eyes, the errors start to increase. Sorry, when we remove the instructions, the errors start to increase in treatment 2. So rather than a reputational effect, it seems that the effect is mostly driven by the increased attention to the information that was provided on top of the bins. And then what we did is also some analysis to understand, how many bins were actually redirected to landfill, which is obviously increasing CO2 emissions, and it's not helping the environment very much. And so this is what we mean with tolerance analysis. And we conclude in the paper that if we assume a homogeneous effect on all bins that we've treated and considered in the experiment, and we consider also, similar university campuses, we could save more than a ton of waste redirected to incinerators or landfill with a simple nudge. And in terms of the long-term effect, we didn't find any significant long-term effect. So when we removed the watching eyes from the instructions, people started to do the same number of mistakes. So they started to displace items in the bin in a similar way as before the intervention. Okay, so this is all from me. Many thanks for listening. Now you know that there are some drop-in sessions that are happening in the Helen Martin studio, still in this building, but in a different room. If you haven't booked these sessions, don't worry, because there are colleagues, and you can wait outside the room and talk to the student ambassadors. They will be happy to help you to talk with my colleagues. And yeah, thank you so much for listening.